Hello everyone, my name is Matthew Wilson, and this is our intro to our assignment today, S4 Stoplight. So what's the description? What are we looking at today? Today we will be designing a controller for a stoplight that operates on a timer and also responds to emergency vehicles. So for our first step, we have our state diagram, which we can see here. So we have our three lights, green, yellow, and red. These alternate through their cycles here. So if it was 0, 0, goes back to green, 0, 1 is going to yellow, followed by another 0, 1 going to red, 1 being our timer, and so our X is pretty much like our emergency, and our Y is like our timer. So if our timer is 1, then it'll move on. If our emergency is 1, it'll automatically go to red, and if they're 0, 0, then they'll stay at themselves. Or if red's already on emergency and it gets an emergency signal, it'll already just stay red. And then once this is over and the timer repeats itself back to the 0, 1, it'll go back to green, and the cycle will continue. Next is our state table, and as you can see here we have 3 greens, 3 yellows, 3 reds. And so what we did is we decided to use a JK flip-flop, 2 JK flip-flops, which go ahead and helps us create our state table. XE for emergency and XT for our timer, which present state will go into our next state here. So we take the present state columns, create these names, go to next state, and then for our flip-flop inputs are the J1, K1, J0, and K0 for our JK flip-flops. And these don't care conditions will come very helpful for simplifying our Boolean equations, as you can see here through our K maps. We have our J0 simplified equation, J1 simplified equation, K0 simplified equation, and K1 simplified equation. So now I will go ahead and show you guys this fully functioning circuit, kind of dive into more of the process of how I created it. Okay, so over here in Logicsim we have our completed circuit. So I'm just going to go ahead and demonstrate some of the input signals, kind of what it does. So if we go ahead and turn on our timer and go ahead and just use our clock as a normal, it will just cycle from red to yellow, and then yellow to red, and then back to green, just like our state diagram poses. Next, we have our emergency signal. So if we go ahead and if we're on green and we go ahead and flick that clock again with a 1, it'll automatically turn to red, and if we run it again, it'll stay on red. And if we go ahead and reset this, and we go ahead and move this over to yellow by turning on a timer here, and then we send an emergency call, go ahead straight to go to red, and then if we use our timer again, still use our clock, go back to green. So if both the input signals are low and the clock just runs, it will not do anything. And then if one of them are high, it'll go ahead and change either to red or just up in that cycle of red, yellow, or green, yellow, red, and then red to green, green, yellow, red, and repeat that cycle. Or if the emergency is high, then it'll go ahead and go straight to red there. And then for whether or not this is a melee or more machine, the easiest way I can tell is actually going back and looking at our state diagram here. With a more machine, there will be more inputs, but we actually have our 3 that we needed originally, so this is why we can tell it's a melee machine. And the difference between using these JK flip-flops versus the T flip-flops, I would say would typically land in like our K maps. I think it becomes more complex when actually building and wiring the circuit, but I'd say it gives us more simplicity when creating our simplified Boolean equations, as it gives us a faster route to doing so. because we are able to make use of more don't care conditions, which, in turn gives us a more simplified Boolean equation. And that's it. That's my circuit today. Thank you guys.